Okay, so today we're going to go through the second part of curve sketching, which is rational function sketching. So part one that we finished, that was polynomials. Now for part two. Okay, so recall what a rational function is. So a rational function, let's say R, is given by the quotient of two polynomials. So we can write it as some polynomial P divided by some polynomial Q. Okay, whatever degree they are. Okay, so we have R of X is some polynomial P of X divided by some polynomial Q of X. Okay, so top, that's a polynomial. And the bottom, that is some other polynomial. So we want to figure out some steps that you can follow to do a rough sketch of these. So before we had a list of things that we could find, and that would help, connect the dots and give us the sketch. So I'll just list them here, and then we're going to add on two new things that we need to find for these cases. So number one, you would look for the x-intercepts. Okay, number two, you would look for the y-intercepts. Number three, you would look for the turning points or inflection points. Okay, so sometimes you have a turning point, but then later on you figure out that it's actually an inflection point. So we'll group these two together. Okay, turning points and inflection points, and we saw some examples with that on Thursday. Okay, and now we're going to add two more things. So for rational functions, we also have two types of asymptotes. So you're familiar with this from high school with the hyperbola, right? You got your vertical asymptote and your horizontal asymptote. The same thing applies for this in general. However, for the vertical asymptote, sometimes there's more than one. So in high school, you did hyperbola with only one vertical asymptote, one horizontal asymptote. Here we'll see it's a bit more complicated. Okay, but the idea is the same. So we have vertical asymptotes. Okay, and the second thing is the horizontal asymptotes. Okay, so these last two, those are the two new things that we're adding to our list. So all the stuff that we covered on Thursday to sketch the polynomials, that still applies. We're still going to do all of that. But additional to that, we have these last two things that we need to find. Okay, so let's go through a very simple example just to get the idea. Then we've got four more complicated examples, and those are expected for the June test. Okay, so if you can do these four, then you're fine for the June test. However, if you need more help, there's the tutorial. Okay, so the tutorial on sketching, you should have all done the first part, finding the turning points and increase and decrease and all of that. Then the second part, that includes the sketching from what we did on Thursday. It also includes the sketching from what we do today. Okay, so that second part, you should finish by the end of this week. Okay, so a very basic example just to get the idea. Let's say we have the function f of x is equal to x over x plus 1. Okay, so it's about as simple as we're going to get. So we've got a linear polynomial at the top and a linear polynomial at the bottom. Okay. Now we can do a little bit of algebra here, and we can rewrite this as minus 1 over x plus 1 plus 1. Okay, a little bit of rewriting, so I'll let you fill in the details for that. But this is what you should have seen in high school, right? So this has the form of a over x plus p plus q. Okay, you should all remember that from high school. Okay, so what does this look like? Okay, so we know we've got the asymptote here at -1 for the vertical because of the p. And then we've got that other asymptote q that will be at 1. So it will be something like that. Okay, and then we just fill in the hyperbola. It will be something like this. Okay, so now let's look at this function again and think about where these asymptotes come from. So firstly, the vertical asymptote, where does that come from? That comes from when the denominator is 0. So when this denominator is 0, the function's going to go up to infinity, and that gives us a vertical asymptote. So we can write here for vertical asymptotes, vertical asymptotes, they occur when the denominator is 0, right? Then the function blows up, and we get ourselves a vertical asymptote. So here we have this q from the bottom is equal to 0. So when the bottom is 0, whatever solution we get for q is equal to 0, that will then give us the vertical asymptote. What about the horizontal asymptote? Well, that is what happens when we take the limit as x goes to plus or minus infinity. When x goes to plus infinity, we see the hyperbola getting closer and closer to that asymptote. Then on the other side, when x goes to minus infinity, again, we see the hyperbola approaching the asymptote line. So that horizontal line is whatever happens to the function when x goes to plus or minus infinity. So here for the horizontal asymptote, okay, we see that occurs when we take the limit as x goes to plus or minus infinity. Okay, this will give us some y value, and that y value is the horizontal asymptote. Okay, so this is how we find these two in general. So in high school, you just read it off as p and q. However, now it's a bit more complicated, so we have to do a little bit extra work. So in general, if you want a vertical asymptote, then the denominator must be 0. That's how you find those. If you want to find the horizontal asymptote, you take the limit as x goes to plus infinity or minus infinity. Either way, you get that horizontal asymptote. Okay, so that's what we're going to do in general for these examples. Any questions on finding these two things? No questions. Okay, let's start off with example 1. Okay, so we have 4 examples to get through, and then 1 homework problem that you can try. So the first one, we have y equals 1 over 1 plus x squared. Let's write that a bit neater, 1 plus x squared. So this is a rational function. So the top is just a 0-order polynomial, just a constant 1. And then the bottom is a quadratic polynomial. Okay, so it's a rational function. Let's follow the steps on how to sketch it. So remember, the first few steps is exactly the same as for a polynomial. You look for x-intercepts, y-intercepts, turning points. The only thing extra you have to do is vertical asymptotes and horizontal asymptotes. Okay, so the first few we've all seen before now. So number 1, let's look for the y-intercept. So for the y-intercept, we let x be 0. If x is 0, we get y as 1. So we got the point 0, 1. Okay, number 2, x-intercepts. In that case, we let y be 0. But if y is 0, there's no x that's going to give us 0, so no solution. Okay, so no x-intercepts, that's fine. Number 3, turning points. Okay, a reminder on turning points. Whatever the function is, we take the first derivative, set that equal to 0. Whatever solutions you get, those will be the turning points. So here we're looking for y prime. Okay, so you got a quotient. You can use the quotient rule for that. We're going to end up with minus 2x over 1 plus x squared squared. Okay, and we want that to be 0 to find the turning points. Now, this only happens when that top part is 0, so x must be 0. And if x is 0, y is 1, so we have a turning point at 0, 1. Okay, now we've got the turning point. What about the intervals of increase and decrease? So that will happen on either side of the turning point. So we draw a number line. We know there's the turning point at x equals 0. So what happens before x equals 0? You can check if x is negative, then we've got a minus in front, so that will make the whole thing positive. So there's a plus. Then if x is positive, we got the minus in front of it, so that makes it negative. So there's a minus. So before x equals 0, the gradient is a positive number, so that means it's increasing. Okay, then at x equals 0, we have the turning point. After x equals 0, the gradient is negative, so it's decreasing. Okay, now if this was just a polynomial, we would stop here and just connect the dots. However, for rational functions, we now need to find the asymptotes. You can do it in whatever order you want, as long as you find both. So let's start off with the vertical asymptotes. Okay, so the vertical asymptotes, asymptotes. Okay, the vertical asymptotes occur where the denominator is 0. So we're looking for x solutions where x squared plus 1 is 0. You're not going to find any, so no solution. Okay, so there are no vertical asymptotes. Right? There might be, there might not be. It depends on what's given. Okay, what about horizontal asymptotes? Okay, remember these are the y values where we take the limit of the function. So let's take the limit as x goes to infinity of 1 over 1 plus x squared. So we've got a fraction. The denominator is getting infinitely large, which means the fraction is getting smaller and smaller. We end up just at 0. So this is the y value for the horizontal asymptote. Okay, at y equals 0. Right, that's everything we need to sketch this. So let's put in our axes. Okay, so we've got x and y. And remember that the x-axis there, where y is 0, that is also a horizontal asymptote. So let's just go over that in pink here so we remind ourselves. Okay, so that pink line there, that is our horizontal asymptote. So whatever we draw, the function needs to go along the asymptote, never cross it. Okay, so just keep that in mind. Okay, so we've got that done. Now let's put in the points that we know. We know that there's a y-intercept at 0, 1, and 0, 1 is also the turning point. Okay, so let's put that here. 0, 1. Okay, so that's the y-intercept. It's also going to be the turning point. Now, before the turning point, the function is increasing up to the turning point. Then after the turning point, it's decreasing. Right? We got that from our number line. So our sketch needs to go along the asymptote up to the turning point because it's increasing. It then turns and then goes down. So increases, turning point, decreases. So we sketch that. So it goes along the asymptote line, increases, turning point, decreases, and then back along the asymptote line. Okay, so we end up with something like this. Okay, again, it goes along the asymptote line, increases because we are on the left-hand side of the turning point. It must turn at the turning point and then decrease to the asymptote line afterwards. Okay, and we end up with this picture. Any questions? No questions. Okay. Again, keep in mind, you might get no vertical asymptotes. You might get one vertical asymptote or two or three. It just depends on the problem. Okay, so just because vertical asymptotes is listed doesn't mean that there's always a vertical asymptote. Okay, so you just need to do a quick check to see if there is or if there isn't. Okay, again, any questions before we move on? No questions. Okay, example 2. Okay, a little bit more difficult than the previous one. It's not too bad. So we have y is equal to x over 1 minus x squared. So now the top is linear and the bottom is quadratic. So it's a little bit more complicated than the last one, but still manageable. Okay, so first few things, exactly the same as before. Y-intercept, x-intercept, turning points. We just follow as normal. Okay, so number 1, y-intercept. We let x be 0. If x is 0, y is 0, so we get 0, 0. Okay, that's our first point. Next, x-intercept. So now we let y be 0. If y is 0 on the left-hand side, then that must mean x is 0 on the other side. So again, we get 0, 0. Okay, so we still only have 1 point, but that's fine. We can do more. So we can look for some turning points. Okay, so we're looking for y prime, the first derivative, set it to 0, and see what we get. Okay, so y prime, you can check this. This is going to be x squared plus 1 over 1 minus x squared squared. Okay, it's just the normal quotient rule. Okay, you can fill that in. Now, the problem is, if we set this equal to 0, then we're not going to have any solutions because x squared plus 1 is never 0. So there's actually no solutions for this. Okay, so there are no turning points. Okay, so that didn't help us too much, but let's see what else we can do. But notice we've got y prime is this thing over here. The denominator is squared, so it's always positive. The numerator is never negative because it's x squared. So positive over a positive, it's a positive, which means y prime is always greater than 0. Okay, so what does that mean? It means the gradient is always positive. What does that mean? It means the function is always increasing. Okay, so when we sketch this, we need to keep in mind that when we're drawing in the lines, we always go from bottom to top. It's always increasing, no matter where we are. So just something to keep in mind. It is always increasing. So whatever connect the dots we do, it must always go up. Okay. If you start drawing down, you're doing something wrong. Okay. Here we see the gradient is always positive. So whatever you're drawing, it must always go upwards. Okay. If you start turning and going down, you've lost the plot there. Okay. We still don't have any new points. So let's look at the asymptotes. Maybe that will help us out. Okay, so far we've got 2 bits of information. We know 1 point at 0, 0, and we know it's always increasing. Okay, but that doesn't help us sketch it, so we need to do more. Number 4, vertical asymptotes. Okay, so vertical asymptotes, that is what happens when the bottom part or the denominator is 0. So we're looking for solutions where 1 minus x squared is 0. Right, I just took the bottom part. We can factor this. So this is going to be 1 plus x, 1 minus x. is equal to 0. That's going to give us two solutions, and so two vertical asymptotes. We're going to get x equals minus 1 as our first vertical asymptote, and x equals 1 as our second vertical asymptote. Okay, there's two of them. Two vertical asymptotes. Okay, so that helps us a bit. What about the horizontal asymptotes? Let's check. Yeah, sorry, asymptotes. Okay, the horizontal asymptotes occur when we take the limit as x goes to infinity. So let's do that. So we want the limit as x goes to infinity of our function x over 1 minus x squared. So this is going to be the limit as x goes to infinity of 1 over minus 2x. But when x goes to infinity, the whole thing goes to 0. So we end up with 0. Remember, this is a y value. So horizontal asymptotes are y equals something. Okay, for the horizontal line. So y equals 0. In other words, the x-axis. Okay, that's going to be our horizontal asymptotes. Okay, there's no more points that we can find. There's no turning points or inflection points or anything like that. So let's try sketch it with what we've got. So we put in our axes. We've got x and y. Now we know that the x-axis is also an asymptote. So let's put that in pink just to remind us. Okay, so whatever we draw, it must always go along this pink line. Okay, if you start cutting through the pink line as x goes to infinity, you're doing something wrong. Okay, so we've got that. We know one point of the function is at 0, 0. So over here, 0, 0, the function has to pass through that point. After that point, it can't pass through because then we're cutting through the asymptote. But at 0, 0, that's fine. Okay. Then we can put in our vertical asymptotes. We've got one at x equals minus 1, and we've got another at x equals 1. So let's put some dotted lines for that. So x equals minus 1, we've got an asymptote there. Usually asymptotes are dotted lines. Okay. And then on the other side, x equals 1, we've got another asymptote there. Okay, like I said on Thursday, please do not measure out, the distances. As long as you label it, I can see what you're doing. Okay, so if it's roughly on one side and then on the other, that's perfectly fine. Okay, don't go there with your ruler saying 1 centimeter, 2 centimeters, 3. It's too much trouble. Okay, just label it. It's fine. All right, so we've got this. That's all we have to work with. Now we have to try fill in the curve. Now, the one thing that's going to help us is that thing about the gradient. Okay, it is always increasing. So whatever we draw, the function must always go. So we're going to start along the asymptote line like we did before, and the function must go up. If you're drawing it down, you're doing it wrong. There's only one thing we can do on that left-hand side. We follow the asymptote line, and the function must go up. So it can only do that. It has to go up. There's no choice in that. Okay, what about between minus 1 and 1? The function must go up. Okay, that's what we know. We don't know anything else. Okay, but we do know it passes through the point. Okay, so it must go up and it must pass through that point. Well, there's only one thing we can really do. The function must go up and it must pass through the point. So it can only do this. There's nothing else you can draw that satisfies that condition. Okay, what about the right-hand side of the asymptote? Again, the function must go up. If you start drawing a function going down, it's wrong. There's only one thing we can do. The function must go up. So it must look like that. Okay. So again, very limited information. We've just got asymptote lines and 1 point. But we also know that thing about the gradient. Okay, so that's enough to sketch it. But again, right, very limited information. So you need to understand what it means for the gradient to always be positive. Okay, you must understand that if the gradient's always positive, the function's always going up. If you don't understand that, then you're stuck. Okay. Any questions on this example? No questions. Okay, next one. Number 3. Okay. This one is about as complicated as it's going to get. Okay, so if you can do this one, you're fine. Okay, so we have y is equal to 1 over x cubed minus 3x. Okay, so again, the top is a 0-degree polynomial, just a constant 1 there. But the bottom is a cubic. Okay, so a little bit more complicated than what we had before, because now it's a cubic. Okay, but same idea. You just follow the steps, get the points, and then connect the dots. Okay, let's go through the first few quickly. So number 1, y-intercept. Okay, so in this case, we want to let x be 0. Okay, if x is 0, we have 1 over 0. That's a problem, so no solution. Right, we can't substitute x equals 0, so we have no solution for that. Okay, so not the best start. Number 2, let's look for the x-intercept. So here we're going to let y be 0. Okay, so left-hand side we got 0. On the right-hand side, the numerator is 1. Okay, well, 1 can't be 0, so again, no solution. Okay, so not looking good so far. Okay, so we've got no y-intercepts, we've got no x-intercepts. Hopefully there's turning points that we can use. So number 3, turning points. Okay, so we want to do y prime. Again, it's a fraction, so you can just use the quotient rule for that. So we end up with y prime is equal to minus 3x squared plus 3. Okay, from the derivative at the bottom with that minus sign from the quotient rule. Okay, all over that bottom part squared. So x cubed minus 3x squared. Okay, and we want this to be 0. Okay, so this is fine. We can solve that top part being 0, so at least there's some turning points. Okay, so we want minus 3x squared plus 3 to be 0. We can solve this, so that's fine. We can take out a minus 3 here. Okay, so we end up with x squared minus 1 is equal to 0. We can factor that as x plus 1, x minus 1. Here we get 2 solutions, so we have 2 turning points. So we get x equals minus 1 from that first one. And if we take that minus 1 and substitute it for y, we get y equals a half. Okay, just substitute it into that top equation, you get y is a half. For the next one, we get x equals 1. And if you just substitute it to get y, we get minus a half. Yeah, that's easy to check. Just put 1 and minus 1. You'll get that. Okay, so for the first one, we get the points minus 1 and a half. And for the second one, we get 1 and minus a half. Okay, so summary so far. No y-intercepts, no x-intercepts, but we've got 2 turning points. So we're going to have to work with that. Okay, so let's look for intervals of increase and decrease. So we've got 1 turning point here at minus 1, and another turning point at 1. What happens in between there? So before minus 1, okay, we look back at the derivative. If we substitute something smaller than minus 1, we get a negative answer, so we can just put a minus. Okay, back here. If we substitute something between minus 1 and 1, like x equals 0, for example, we're going to get something positive, so we can put a plus. And then after 1, we go back here. So like x is 2 or 3 or something like that, just something after 1, we end up with something negative again, so we can put a minus. Okay, so for the first part, the gradient was negative, so we know it's decreasing. Then at minus 1, it does the turning. Then between minus 1 and 1, gradient's positive, so it must be increasing. Then we get another turning point at 1, and then after 1, the gradient is negative, so it must be decreasing again. Okay, so we know where the function's going up. Turning points, function goes down. Turning points, function goes up again. Okay, so that's all the stuff we would have done. Now we've got the extra 2 things of vertical asymptotes and horizontal asymptotes. So number 4, vertical asymptotes. Okay, so this is where that bottom part is 0. So we just take the denominator as is. X cubed minus 3x is equal to 0. Okay, again, whatever's at the bottom there, we set that to 0 and we try and solve. Okay, so we've got x cubed minus 3x, common factor of x. We can take that out. So we get x squared minus 3 is equal to 0. Okay, then that second part there, x squared minus 3, we can factor that further. So we get x plus root 3 and x minus root 3. Okay, so we're going to get three vertical asymptotes. So the first one from that very first bit, x equals 0, that's going to be one of them. The second bracket, that's going to give us x equals minus root 3. That's the second asymptote. And finally, the third term there, x plus root 3, x minus root 3, that will give us x equals root 3. Okay, so 3 vertical asymptotes. Okay, what about horizontal asymptotes? Let's have a look for those. Okay, horizontal asymptotes. Okay, so we want to take the limit as x goes to infinity. So this will be limit x goes to infinity and whatever function's given. So in this case, we have 1 over x cubed minus 3x. Okay, this one's very easy. When x goes to infinity, that whole bottom part's going to go to infinity, so the fraction goes to 0. So we have y equals 0. Okay, just something to notice with these asymptotes. X equals 0, that's going to be the y-axis. So that's going to be one of the asymptotes. And then y equals 0, that's the x-axis. That's also going to be an asymptote. Okay, so when you're putting in your axes, just remember that both of those are going to be asymptotes. So maybe in the test or something, you want to put it in a different color or something, just so that you can see. Okay, like we did for this one. So the y-axis is just the y-axis. We leave it as is. But the x-axis is also an asymptote, so maybe you want to put it in a different color. Okay, but I'll leave that to you. Okay, so we've got our axes, x and y. And we know from y equals 0, the x-axis is going to be an asymptote. So we can use pink again for that. Okay, again, the color is just so you can see the difference. Okay, if you don't want to do it, that's fine. And then from the previous step, x equals 0, that's also an asymptote. Again, if you want to put that in a different color, that's fine as well. Okay, so we got those as asymptote lines. We've got another two asymptotes. There's one at x equals minus root 3 and one at x equals root 3. So let's fill those in. For those, we don't need a color. We can just do the dotted line. So this is x equals minus root 3. And then we have the same thing on the other side, x equals plus root 3. Okay, so that's all the asymptotes taken care of. Remember, there's no y-intercept and there's no x-intercept, so we can skip those. But there are two turning points, so we need to fill those in. One of them is at minus 1/2, so we can fill that one in, and the other is 1 and minus 1/2, so we can fill that one in. So minus 1.5, let's put that up here. Okay, and then on the flip side, we've got 1 and minus 1/2 as the other one. So that's down here somewhere. Okay, we don't have any other points to fill in, so we're going to have to work with this. Okay, so from left to right, let's see what happens with the increase, decrease. Okay, so we're going to draw from left to right. Let's start here. We see that it is decreasing. So going left to right to the first asymptote, to the turning point there, it's going to be decreasing. So whatever we draw, it must be going down. Well, there's only one thing we can do. We can draw the function going down. Oh, there's no other way of drawing the function going down. That's it. Okay, next. After the asymptote to the turning point, it's still going down. So what we want to do is go along the asymptote, draw the function going down, and then it must go through that point. So the function still is going down, but it must pass through that point. So it must do something like this. Okay, it must still go down. Again, look at how I drew it. Top to bottom, the function goes down because it's decreasing. Okay, next bit. From minus 1 to plus 1, it is now increasing. So instead of taking my pen going down, you now take your pen and go up. Now you laugh, but when you get to the thing, you're going to draw all funny squiggles. Yeah, last year the sketching was very, very funny. Okay, so again, we go to that point and we must take our pen and go up. There's only one way to do that. It must go up. Okay, that's the only thing it can do. You start at the turning point and it must go up. Okay, what about on the other side? Well, function's still going up. There's only one way to do that. You start at the bottom and you have to go up. Nothing else you can do. Okay, so now we're at x equals 1. What happens after that? So from 1 onwards, it is now decreasing. So you take your pen, you start at the top, and it must go down. I mean, there's only one way to do that. We're going to start at the point and go down. So I must do that. Nothing else you can do. You start there, you go down. That's the only thing you can draw. Then the next part, it's still going down. There's only one thing you can do. You start at the top and it must go down. Okay, and we end up with this. Okay, it looks very complicated. As a finished thing, it looks very complicated. But what did we do? From left to right, we drew the graph going down. In the middle, we drew the graph going up. And then on the right, we drew the graph going down. That's all we did. Okay, afterwards, it looks complicated. But all we did was go down, go up, go down. Okay, so the actual process is not very complicated, even though at the end it looks complicated. Okay, just follow the steps. Right, any questions on this one? All good. Okay, this is as complicated as it's going to get. Okay, with the 3 asymptotes and the 2 turning points, that's as difficult as you're going to be tested on. Okay, so for the June test and the SUP exam, for those that are writing the SUP exam, if you can do this one, you can do whatever's asked. Okay, any questions? No questions. Okay, I thought there would be at least one with this. Okay, that's fine. Next one. Example 4. It's pen. Example 4 is pretty easy, but again, make sure you get all of the individual steps correct, right? Because if you mess up with the derivative, then your turning points are wrong, then your intervals of increase and decrease are wrong. It just goes, bad all the way through. So please take your time. Okay, there's a lot of time allocated for this question. So please take your time on each step and check your working. At the end, if it's wrong, and you come to me saying, oh, but part marks and stuff, I'm going to tell you, no, you should have checked your work. Okay. Please, time is given to you to check your work. Check your work. Okay, example 4. Y is equal to x over x squared plus 1. Okay, so we want to try and sketch this. So the first 3 things, exactly the same as for the polynomials. Y-intercept, x-intercept, turning point. That's your go-to for both cases. Okay, number 1, y-intercept. So we let x be 0. Okay, if x is 0, y is 0, so we get 0, 0. X-intercept. So now y is 0. Okay, left-hand side is 0, so that means that x is 0, so we get 0, 0. Okay, so see these first 2, that should be very quick. Right, you just substitute and get the points. Okay, not much involved there. Turning points. Let's see what that is. Okay, again, for turning points, we want to find the first derivative, set it equal to 0, and see what you get. Again, quotients, your f over g, so just use your quotient rule for that. So we end up with y prime is equal to 1 minus x squared over x squared plus 1, and then you square the bottom. Okay, so we end up with that, and we want this to be 0. Okay, that's going to give us the turning points. So top part being 0, that's easy enough to solve. 1 minus x squared is 0. So 1 plus x, 1 minus x is 0. So in the first case, we get x equals minus 1. And in the second case, x equals 1. Okay, so that's the x's done. We go back up to the top. If we substitute minus 1, we're going to get minus a half. If we substitute 1, we just get a half. So the y values are minus a half and a half. Okay, very quick substitution. Okay, you can even do that in your head. Okay, so we get minus 1, minus a half as our first turning point. And then the second one there, that's just 1 and a half. Okay, turning points done. Next, intervals of increase and decrease. So we draw on our number line. We got one turning point at minus 1, another one at 1. What happens in between? If you pick a number smaller than minus 1, we go back up here. So if we pick something smaller than minus 1, we end up with a negative. So we put a minus. If we pick something between minus 1 and 1, like 0, okay, then we end up with something positive. So we can put a plus. If we go back up here, if you put something bigger than 1, like 2, for example, or something else there, we get a negative again. So we can put a minus. Okay, so that's very quick. You just substitute and check the sign. If you get a negative answer, we know it's decreasing. Okay, you got a plus answer, we know it's increasing. Okay, and then the last bit, we got a negative answer, so it must be decreasing. Okay, so we're done with all of that. Now the vertical asymptotes and the horizontal asymptotes. So number 4, vertical asymptotes. So we want this bottom part to be 0, whatever's at the bottom there. So x squared plus 1 is equal to 0. Okay, no solutions for that, so there's no vertical asymptotes. Okay, so we don't have to worry about any of those. What about the horizontal asymptotes? Let's check that. Okay, so for this one, we need to take the limit. So this is going to be the limit as x goes to infinity. Whatever's given, in this case, it is x over x squared plus 1. So that's going to be the limit as x goes to infinity of 1 over 2x. Okay, the bottom's going to go to infinity, fraction's going to go to 0, so we just get 0. Okay, pop quiz. What did we do in that second step? Last line, from the first thing to the second thing. What did we do? Sorry? What's the process called? Yeah? L'Hopital's rule, thank you. Just checking, because I'm writing all of this, and if you don't even know what we're doing, that's a problem. Hands up if you knew that was L'Hopital's rule. That's not everyone. Okay. That's fine, still got time for the June test, so please check up on that. So the rest of you that kept your hands down, when I did that step, what did you think I was doing? Sorry? Dividing by x squared. Not quite. Okay. Please think about that for the June test. Okay, so we have that as our horizontal asymptote, but y equals 0, that is also the x-axis, so we need to be careful with that. Okay, sketch this. So we have x and we have y, and then remember the x-axis is also an asymptote, so let's just put a pink line to remind ourselves. Okay, we don't have much to work with. We've just got 3 points. So the first point that was right at the beginning here, 0, 0. So let's fill that in. That's going to be right there. Then we have 2 other points that we can work with. The turning point, -1, -1/2. And then on the other side, 1.5. Okay, so -1, -1/2, somewhere there. Okay, again, as long as you label it, I know what's going on. Doesn't matter where the point is, really. Okay, so -1, -1/2, somewhere there, just label it. Then in the first quadrant, we have 1.5. So somewhere up there, we have this point, 1.5. Okay, so we've got our points. Now we need to connect the dots. Remember, from left to right, it's going to be decreasing, increasing in the middle, and then decreasing. So whatever we do with our pen, we must follow down, up, down. So just keep that in mind. Down, up, down. Okay, so from left to right, we must go down. So it must look something like this. Turning point must go up, must go down. So it must look something like that. Again, down to the turning point, up, and it must go through that point. Next turning point, and then back down. So something like that. Okay, again, very rough sketch, as long as I can see turning points and so on. Please don't spend too much time making it perfect. Okay, as long as I can see the asymptote lines and your turning points, should be fine. Okay, rather use your time for other things. I don't want to see very perfect graphs. Rough sketch so I can see what you're doing. 100% okay with that. Okay, what I'm not okay with is if you just draw straight lines connecting everything. I saw that last year, they all got straight 0. So if you decide from that turning point to that turning point, you just draw a straight line, you get 0. Okay. So when I say a rough sketch, please don't be stupid and start drawing straight lines everywhere. Yeah. Any questions on this one? No questions. Everyone good. Okay, then just the homework problem, and then we're done with the lectures for the semester. Again, with that, please check with your other lecturers. They might continue, but for maths, we're done. Okay, homework problem. Y is equal to x squared minus 2x plus 1 over x squared plus 1. Okay, so quadratic at the top, quadratic at the bottom. See what you can do with that. Yeah, again, if you can do this one, you're fine. Okay, so please don't go home and try to do 100 different examples. If you can go through these again, especially that question 3, if you can do that one on your own, you're fine. Okay, please don't go, do everything in the textbook. If you can do question 3, you're fine. If you can do the homework, you're fine. Please don't stress too much about it. Okay, but if you can't do number 3 on your own and you can't do the homework on your own, then you're in a lot of trouble for the June test. Okay, it goes both ways. If you can't do this homework and you're struggling, you have to come and see me before the June test. That June test problem, you've got no hope of doing it if you can't do this one. Okay, so please just keep that in mind. Any questions? No questions. Okay, so we'll leave it at that for the